Welcome. Today we're diving into the world of databases and SQL. Databases are the backbone of modern applications, storing and organizing data efficiently. Whether you're building a website, an app, or analyzing data, understanding how databases work is essential. In this video, we'll start from the basics and gradually move to advanced SQL queries. You'll learn how to retrieve, filter, and aggregate data, and by the end, you'll be able to handle complex queries with confidence. Let's begin our journey by understanding what a database is and why it's so important in today's digital world. SQL stands for Structured Query Language. It's the standard language used to communicate with relational databases. With SQL, you can ask questions about your data, update records, and manage the structure of your database. Think of SQL as the bridge between you and your data, allowing you to interact with information in a structured and efficient way. Throughout this video, you'll see how SQL commands can help you retrieve exactly the data you need, no matter how large or complex your database becomes. Relational databases organize data into tables, much like a spreadsheet. Each table contains rows and columns, where columns represent data fields and rows represent individual records. This structure makes it easy to store, retrieve, and relate information. For example, you might have a table for customers and another for orders, linked by a customer ID. Understanding this structure is key to writing effective SQL queries, as it allows you to connect and analyze data from multiple tables seamlessly. Start with the basics of SQL syntax. Every SQL statement follows a specific structure, making it easy to read and write. The most common command is select, which is used to retrieve data from a table. For example, select from customers will fetch all records from the customers table. As you get comfortable with this syntax, you'll find it straightforward to build more complex queries by adding conditions, sorting, and grouping your results. Select statement is your primary tool for pulling data from a database. By specifying the columns you want, you can focus on just the information you need. For instance, select name email from customers will return only the names and emails. This targeted approach helps you work efficiently, especially when dealing with large datasets. As you practice, you'll see how select forms the foundation of almost every SQL query you write. Narrow down your results, use the where clause. This allows you to filter records based on specific conditions. For example, select from customers where city equals London will return only customers from London. The where clause is powerful for focusing your queries and extracting meaningful insights from your data. You can combine multiple conditions using and or to refine your search even further. Sometimes you want your results in a specific order. The order by clause lets you sort data by one or more columns. For example, select from customers order by name ASC will list customers alphabetically. You can also sort in descending order using DESC. Sorting makes it easier to analyze and present your data, especially when you're looking for top values or trends. In working with large tables, you might want to see only a portion of the results. The limit clause helps you do just that. For example, select from customers limit 10 will show only the first 10 records. This is especially useful for previewing data or when you only need a sample for analysis. Remember, limit can make your queries faster and more manageable. Aliases allow you to rename columns or tables in your query results, making them easier to read. For example, select name as customer name from customers will display the name column as customer name. Aliases are especially helpful when working with complex queries or when you want your results to be more descriptive. They don't change the actual data, just how it's presented in your results. Aggregation functions like count help you summarize data. For example, select count asterisk from customers tells you how many customers are in your table. This is useful for quick overviews and reporting. Aggregation functions are powerful tools for analyzing trends and making data-driven decisions, and we'll explore more of them in the next scenes. Beyond count, SQL offers other aggregation functions like sum, AVG, min, and max. These let you calculate totals, averages, and find the smallest or largest values in a column. For example, select AVG from customers gives you the average age. These functions are essential for data analysis, helping you uncover patterns and insights quickly. Group by clause lets you organize data into groups based on one or more columns. For example, select city count asterisk from customers group by city shows how many customers are in each city. Grouping is crucial for summarizing data and generating reports, especially when combined with aggregation functions. Aware filters individual records, HAVING filters groups after aggregation. For example, select city count asterisk from customers group by city HAVING count asterisk 5 only shows cities with more than 5 customers. HAVING is essential when you want to focus on significant groups in your data analysis. SQL allows you to combine multiple conditions using and, or, and not. This gives you precise control over your queries. For example, select from customers where city equals London and age 30 returns customers from London who are over 30. Mastering these logical operators helps you extract exactly the data you need. Like operator helps you search for patterns in text data. For example, select from customers where name like A% finds all customers whose names start with A. You can use wildcards like % and to match multiple or single characters. Pattern matching is useful for flexible searches and data exploration. IN operator lets you specify multiple values in a where clause while between checks for a range. For example, select from customers where city in London, Paris finds customers in either city. Between is great for ranges like select from orders where date between 2023-0101 and 2023-1231. These operators make your queries more concise and powerful. Null represents missing or unknown data in SQL. It's important to handle nulls carefully as they can affect your results. For example, select from customers where email is null finds customers without an email address. Use is null and is not null to check for these values and ensure your queries are accurate. One of SQL's most powerful features is the ability to join tables. Joins let you combine data from multiple tables based on related columns. For example, you can link customers and orders using a customer ID. This opens up endless possibilities for analysis and reporting, as you can pull together all the information you need in a single query. An inner join returns only the rows that have matching values in both tables. For example, select from customers inner join orders on customers id equals orders customer id gives you all customers who have placed orders. Inner join is the most common type of join and is essential for combining related data efficiently. Left join returns all rows from the left table and matching rows from the right table. If there's no match, you'll see nulls for the right table's columns. For example, select from customers left join orders on customers id equals orders customer id shows all customers, even those without orders. Left join is useful for finding unmatched records. A right join is similar to left join, but it returns all rows from the right table and matching rows from the left. If there's no match, you'll see nulls for the left table's columns. This join is less common but useful when you want to keep all records from the right table regardless of matches. Full outer join returns all rows from both tables, matching them where possible. If there's no match, you'll see nulls for the missing side. This join is great for combining all data, even if some records don't have a match in the other table. It's especially useful for comprehensive reports and data reconciliation. Cross join returns the Cartesian product of two tables, meaning every row from the first table is combined with every row from the second. This can create a lot of results, so use it carefully. Cross join is useful for generating combinations such as pairing every product with every store. Self join is when a table is joined with itself. This is useful for hierarchical data or finding relationships within the same table. For example, you might use a self join to find employees who report to the same manager. It's a powerful tool for exploring complex data structures. Subquery is a query within another query. Subqueries help you perform complex operations like filtering results based on calculations or other tables. For example, you can use a subquery to find customers who placed the largest order. Subqueries add flexibility and depth to your SQL skills. A view is a saved SQL query that acts like a virtual table. Views help you simplify complex queries and reuse them easily. For example, you can create a view for active customers and reference it in other queries. Views make your database easier to manage and your queries more readable. Indexes are special data structures that speed up data retrieval. Think of them like an index in a book, helping you find information quickly. For example, adding an index to the email column in the customers table makes searches faster. Indexes are crucial for performance, especially as your database grows. To create an index, use the create index statement. For example, create index IX email on customers email adds an index to the email column. Indexes make select queries faster, but they do use extra storage and can slow down updates. Use them wisely for columns you search often. Indexes are most useful on columns you search or sort frequently, like IDs or emails. However, too many indexes can slow down inserts and updates. It's important to balance performance and maintenance. Analyze your queries and add indexes where they'll have the biggest impact. Composite index covers multiple columns, making searches involving those columns faster. For example, an index on city age helps queries that filter by both city and age. Composite indexes are powerful for optimizing complex queries, but they require careful planning to match your most common searches. Unique index ensures that all values in a column are different. For example, adding a unique index to the email column prevents duplicate emails. This helps maintain data integrity and prevents errors. Unique indexes are essential for columns that must be unique, like usernames or IDs. If you no longer need an index, you can remove it with the drop index statement. For example, drop index IX email deletes the index on the email column. Removing unused indexes can improve performance for inserts and updates, keeping your database efficient. SQL includes many built-in functions for manipulating data, such as string, date, and mathematical functions. These functions help you clean, transform, and analyze your data directly in your queries. For example, you can format dates, calculate ages, or extract parts of a string. Mastering these functions expands your SQL toolkit. String functions let you manipulate text data. For example, you can use upper name to convert names to uppercase or concat first name, last name to combine columns. These tools are essential for cleaning and formatting your results, making your data easier to use and understand. Date functions help you work with dates and times. For example, you can use now to get the current date or datediff end date start date to calculate the difference between two dates. These functions are vital for time-based analysis, such as tracking orders or calculating customer ages. Mathematical functions let you perform calculations in your queries. For example, you can use round price to round prices or abs value to get the absolute value. These functions are useful for financial analysis, reporting, and data transformation. Every column in a database has a data type such as integer, varchar, or date. Choosing the right data type ensures your data is stored efficiently and accurately. For example, use integer for ages, varchar for names, and date for birthdays. Understanding data types helps you design better databases and write more reliable queries. Constraints enforce rules on your data such as requiring a value or ensuring uniqueness. Common constraints include primary key, unique, not null, and foreign key. These rules protect your data's integrity and prevent errors, making your database more robust and reliable. Primary key uniquely identifies each record in a table, while a foreign key links records between tables. For example, customer ID might be a primary key in the customers table and a foreign key in the orders table. Keys are essential for maintaining relationships and ensuring data consistency. Normalization is the process of organizing your database to reduce redundancy and improve efficiency. This involves splitting data into related tables and using keys to link them. Normalization helps keep your data clean, consistent, and easy to maintain, especially as your database grows. Denormalization is the opposite of normalization. Sometimes you combine tables or duplicate data to improve performance, especially for reporting. While it can speed up queries, it may increase storage and maintenance needs. Use denormalization carefully, balancing speed and data integrity. Transaction is a group of SQL statements executed as a single unit. Transactions ensure that your database stays consistent, even if something goes wrong. For example, transferring money between accounts should either complete fully or not at all. Transactions are vital for reliability in multi-step operations. ACID stands for atomicity, consistency, isolation, and durability. These properties guarantee that database transactions are processed reliably. Atomicity means all or nothing, consistency ensures valid data, isolation keeps transactions separate, and durability means changes are permanent. Understanding ACID is key to building robust applications. Writing efficient queries is crucial for performance, especially with large databases. Use indexes, avoid unnecessary columns, and write clear conditions. Analyze your queries with explain to see how they run. Optimization ensures your applications stay fast and responsive as your data grows. Congratulations, you've covered the essentials of databases in SQL, from basic queries to advanced topics like joins and indexing. With these skills, you can efficiently retrieve, filter, and aggregate data from relational databases. Keep practicing and exploring more advanced SQL features to deepen your understanding. The more you use SQL, the more powerful and flexible your data analysis will become. Good luck on your SQL journey.